Typhoon Vamay formed on December 2001 and is notable for being one of the most unique tropical cyclones ever recorded due to its extremely low latitude genesis. Occurring at just 1.4 degrees north, Vamay holds the record for the closest a typhoon has ever formed to the equator, where conditions for cyclone formation are typically unfavorable. The rarity of this event, combined with its unusual meteorological setup and its impact on Singapore and Malaysia, has made Typhoon Vamay a significant case study for most meteorological setup. The formation of Typhoon Vamay was highly unusual due to strange environmental conditions at the time. Typically, tropical cyclones require the Coriolis effect to initiate rotation, which is weak towards the equator. However, a combination of specific factors came together to allow for Vamay's development. Monsoonal surge. A strong surge in the northeast monsoon was a key factor in Vamay's development. In December 2001, a monsoonal trough was unusually extended southward over the South China Sea, bringing with it abundant moisture and instability. The surge from the northeast helped initiate low-level vorticity, compensating for the lack of the Coriolis effect nearer towards the equator. In early December, a weak low pressure had been lingering around the southern part of the South China Sea. Over time, this system slowly organized, aided by the strong monsoonal surge, which forced the development of a circulation. Sea surface temperatures in the region were around 28 degrees Celsius or 82 degrees Fahrenheit, which is warm enough to fuel cyclone development. Although temperatures near the equator can be warm, they are often insufficient for cyclone formation without other contributing factors, which in this case enhanced the low-level convergence and the atmospheric moisture. Due to its proximity towards land and the equator, Vamay had a very narrow window for intensification. As the system drifted westward under the influence of a low-level flow, it consolidated rapidly, becoming a tropical depression on December 26, 2001, off the coast of Borneo. That was recognized at 1.45 degrees north in latitude, a remarkable feat, considering tropical cyclones occur at least typically at around 5 degrees north or south of the equator. On December 27, 2001, as the system moved westward and northwestward, it rapidly intensified, reaching tropical storm strength on December 27th. The system had well-defined convection and quickly organized into a compact cyclone. Despite its small size, it had powerful winds. On December 27th, later that exact same day, Vamay strengthened to a typhoon, with maximum winds sustained of around 85 miles per hour, just before making landfall towards southern Malaysia. This rapid intensification was aided by the convergence of low-level winds from the monsoonal surge, as well as enhanced convection over the warm sea surface. Vamay made landfall near Johor, Malaysia, around midday on December 27th. It maintained typhoon intensity upon landfall, an extremely rare occurrence of typhoons directly impacting Malaysia. Its close proximity to Singapore also brought heavy rain and strong winds to the city-state. The worst impacts were confined to southern Malaysia. As previously discussed, this was a really unprecedented event. So the impacts. Vamay's landfall in Johor, Malaysia brought heavy rain and winds. It caused significant flooding with over 13 inches or 330 millimeters of rain reported in some areas. The storm also caused wind damage to trees, infrastructure. Singapore experienced its worst flooding in decades, with strong winds uprooting trees and causing significant power outages. Vamay's unexpected development in the maritime region caused disruptions to shipping traffic. Several vessels were caught off guard by typhoon's rapid intensification. South China Sea, being a critical commercial shipping route, saw several incidents of stranded or even damaged ships. Vamay is recognized as a very short-lived typhoon, being one of the shortest-lived typhoons within its entire life cycle, from tropical depression to dissipation, lasting less than 3 days. Unusual December formation. Most typhoons in the northwest Pacific form between June and October, December typically being a quiet month, except for exceptions obviously, such as 2016. Vamay's development in late December made it one of the few typhoons to do so. The recovery, Malaysia and Singapore undertook recovery efforts. Floodwaters took several days to recede in some areas of Johor, and damaged infrastructure had to be repaired. Although the storm's overall death toll was low, economic impact was very significant due to flooding and disruptions. In conclusion, meteorologists and climate scientists continue to study conditions that allowed Vamay to develop, examining whether global climate change may have led to more frequent cyclones in lower latitude regions. Although no definitive link has been established yet, Vamay's unusual characteristics have opened new avenues into the research of tropical cyclone formations and behavior. Typhoon Vamay 2001 remains as remarkable and unprecedented tropical cyclone in meteorological history, with its formation near the equator challenging long-held beliefs about tropical cyclone development and leading to new insights into weather science.